Hey everyone, and welcome back to The Explainer. So today, we're looking way past those standard nutrition labels to unpack something pretty incredible. We're talking about the hidden metabolic engine of the human body, dietary fiber. Honestly, we're going to do a complete rebrand on how you think about this absolutely crucial nutrient. Now, right out of the gate, I want to pitch you a bit of a paradox. Can eating more food actually make you absorb fewer calories? It sounds like magic, right? But by the end of this explainer, you're going to see exactly how the hidden metabolic tools inside our food make this a proven scientific reality. It's a total game changer.
All right, let's jump into section 1, the Great Fiber Gap.
Okay, let's dive into this. When we look at the data from the USDA and the Institute of Medicine, the recommended daily intake is set at 38 grams for men and 25 grams for women. But here's the crazy part. The average daily intake is hovering way down at just 15 to 16 grams. We are literally operating on less than half the fuel our metabolic engines need to actually function properly.
So, where exactly is this massive gap coming from? Well, legumes, think beans and lentils, and dark green vegetables are the food groups furthest from our recommended intake levels. And really, it comes down to our modern reliance on ultra-processed diets. When we refine grains and heavily process our foods, we're physically stripping away these essential plant components. It basically leaves us starved for the exact materials our bodies rely on to regulate our health.
Moving on to section 2, more than just roughage.
To understand fiber's true power, we kind of have to dismantle the old stereotype of it just being plumbing aid. There are two main varieties here. First, you've got insoluble fiber. This is the structural framework of plants, like the strings in celery or the skin of an apple. It adds physical bulk to our stool and speeds up transit time. That's your classic roughage. But then we have soluble, or viscous fiber. You find this in oats, beans, the soft inside of fruits. It actually dissolves in water, and guys, that is where the physiological magic happens. See, when it dissolves, it creates viscosity. Basically, think of viscosity as a resistance to flow. When these viscous fibers hydrate in your stomach and small intestine, they form this thick, gel-like matrix. And that's absolutely crucial, because that gel creates a physical barrier. It literally thickens your food into a slow-moving paste, which delays glucose from rapidly diffusing into your bloodstream. Boom, flattened blood sugar spikes. But wait, it gets better. This gel also physically traps bile acids. So to replace that trapped bile, your liver is forced to pull LDL, the bad cholesterol, straight out of your bloodstream. You are actively lowering your cholesterol just through the sheer mechanics of digestion.
Which brings us to section 3, the calorie excretion secret.
Now, what's really interesting about this next finding is this specific number, 116. There was this fascinating clinical trial done at the Advent Health Translational Research Institute. They had participants consume the exact same amount of total calories, but on two very different diets. Well, the group eating a high-fiber whole foods diet ended up absorbing, on average, 116 fewer calories every single day. Because of the fiber, those calories were literally carried right out of their bodies in their feces. No way, right? Science calls this phenomenon the anti-nutritive effect. It sounds like a bad thing, but it's actually incredible. Because fiber is so bulky and viscous, it acts like a net, physically ensnaring dietary fats and carbohydrates. Your own human digestive enzymes literally can't reach those calories to break them down. It's a completely natural calorie blocker. In fact, this explains why the famous Pounds Law study found that dietary fiber intake was the single strongest predictor of successful weight loss and dietary adherence. It fills you up while simultaneously carrying unabsorbed calories straight out of your system. Let's travel a bit further down the gut for section 4, feeding your virtual organ. I want you to just consider this ratio for a second. The bacteria in your intestines outnumber your actual human cells by roughly 10 to 1. Seriously, let that sink in. When you look at pure cell count, you are only about 10% human. So when you eat fermentable dietary fiber, the exact kind your human enzymes can't digest, you are actually feeding this massive virtual organ inside of you that isn't human at all. So what happens next? When your gut bacteria feast on this fiber through anaerobic fermentation, they pump out these metabolic byproducts called short-chain fatty acids, or SCFAs. You can think of SCFAs as the vital communication link between your gut microbiome and your systemic health. They're basically the chemical text messages your bacteria send to the rest of your body to keep the whole operation running smoothly. And this brilliantly illustrates what these SCFAs can actually do. They've got superpowers. First up, butyrate. This is the absolute preferred fuel for the cells lining your colon, and it's heavily linked to inducing programmed cell death and cancerous cells. Pretty amazing. Second, acetate. This incredibly powerful acid actually crosses the blood-brain barrier, heading straight up to your central nervous system to naturally suppress your appetite. And third, propionate, which travels straight to the liver to actively inhibit your body from synthesizing its own cholesterol. And all of this builds into an entire hormonal cascade. Beyond just the direct effects of those fatty acids, fermenting that fiber stimulates your gut's enteroendocrine cells to release hormones like GLP-1 and PYY. Now, if GLP-1 sounds familiar to you, it's because it's the exact same hormone targeted by today's massive blockbuster weight loss drugs. Your gut already has the ability to produce this hunger-suppressing, insulin-regulating hormone totally naturally, but, and this is a big but, only if you feed your bacteria the fiber they need to trigger that release. All right, let's make this actionable. Section 5, closing your fiber gap.
Let's start with a really cool kitchen hack, the science of retrogradation. Check this out. If you cook a starchy food, like a potato or some rice, and you eat it while it's hot, you're consuming regular, easily digested starch. But if you take that cooked potato, let it cool completely in the fridge, and then eat it, even if you reheat it later, by the way, the molecular structure actually changes. The cooling process creates what's called type 3 resistant starch. It literally resists digestion in your small intestine. So you just turned a standard carb into a highly fermentable fiber that perfectly feeds your microbiome.
Now, a quick word of caution as you start stepping up your fiber game. If you suddenly dump loads of it into your system tomorrow, your microbiome is going to go into overdrive. We're talking gas, bloating, cramping, the whole shebang. So follow these 3 rules. Step 1, go slow. Just add a few grams every couple of days to let your gut bugs adjust. Step 2, and this is absolutely non-negotiable, drink extra water. Fiber acts like a sponge in your gut. Without enough water, it causes constipation instead of curing it. And step 3, keep the skin on your produce, the skin of apples, pears, potatoes. That's where a massive percentage of that structural, insoluble fiber is hiding. So as we wrap up this explainer, I want to leave you with this final kind of provocative thought. Remember, you are only 10% human cells. So the next time you sit down for a meal, I want you to look down at your plate and ask yourself, what are you feeding the other 90% today? Are you giving your microbiome the structural fiber and those fermentable super tools it needs to protect your heart, regulate your weight, and fuel your hidden metabolic engine? Start closing that fiber gap, and trust me, your entire body will thank you. Thanks so much for joining me today, and keep learning.